Question 4. Again, we're dealing with a normally distributed random variable with a non-standard mean and standard deviation. So what we have to do in order to calculate probabilities is we have to convert it to a standard normal distribution. As a reminder, our formulas for converting a non-standard normal random variable to a standard one is we take our random variable, subtract its mean, and divide by its standard deviation to get a corresponding z-score. To go from z-score back to our non-standard random variable is we can simply rearrange this formula and solve for x, and that'll give us this equation right here. All I've done is I've multiplied by sigma to bring it over to this side and then added the mu to isolate x. We'll be using these two a lot. Okay, so part A wants us to find the percentage of patients with a stress score lower than 6, knowing that the stress scores have a mean of 7.59 and a standard deviation of 0.73. In other words, we want to find the stress score such that the probability that you have one lower than that score, we want to find the probability that your stress score is less than 6. There we go. Let me write this down here to give me some more space. Okay, so I want to find the probability that our stress score is less than 6. I'm calling x our random variable, the score. So in order to use my z-table, I need to convert to the z-score. So I'll use this first formula here. So this is equal to the probability that z is less than, and I'm going to convert 6 to a z-score. So I take 6 minus the mean of our random variable, which we're given is 7.59. We're going to divide by our standard deviation, which is 0.73. So I can plug this into my calculator and get that 6 minus 7.59 divided by 0.73 is negative 2.17. So now, using my z-table, I want to find the area to the left of negative 2.17. I can just find negative 2.17 on my z-table and read off the corresponding probability. Negative 2.1 is here. Negative 2.17 is therefore, the area to the left of negative 2.17 is therefore 0.0150. Therefore, the probability that a patient will have a stress score lower than 6, or in other words, the percentage of patients with a stress score lower than 6, is 0.015, which is 1.5%. Okay, let's move to part B. What is the probability that a random patient will have a stress score between 7 and 8? In other words, what's the probability that x, our score, is between 7 and 8? All right, so as always, first thing I want to do in order to calculate the probability is I need to convert to the z-score. So I'll bring back my formula. So to convert 7 to a z-score and to convert 8 to a z-score, I'll do 7 first. 7 minus the mean, 7.59, divided by our standard deviation of 0.73. Next, I'll convert 8. Do 8 minus 7.59 divided by 0.73. I'll plug that into my calculator, and I should get negative 0.81 on this side. And on the right side, I should get 0.56. So now, draw my picture of a standard normal. I want the probability that C is between negative 0.1 and 0.56. In other words, I want to find this shaded area right here. Now the z-table gives me the area to the left of any z-score. So if I find the probability or the area corresponding to z equals negative 0.56, it'll give me all of this area to the left. I just want the shaded area, so I'm going to subtract out the portion of that I don't want, which is the area to the left of negative 0.81. So this is equal to the area to the left of 0.56 minus the area I don't want, which is the area to the left of negative 0.81. I'll substitute these with the areas using my z-table. So I want the area to the left of 0.56. Go to my positive side of the table. Oh, sorry, my negative side. Positive 0.56. 0.56. So that area is 0.7123. The area to the left of 0.56 is 0.7123. Then I want to subtract the area to the left of negative 0.81. So I'll find z equals negative 0.81 in my table. 0.8 is here. Negative 0.81 is here. So the area to the left of negative 0.81 is 0.2090. So I just plug in this into my calculator. 0.7123 minus 0.209. I should get 0.5033. Therefore, the probability that a random patient has a stress score between 7 and 8 is 0.5033, or approximately 50%. All right, last part. Let's do part C. So the psychologist says that anyone with a stress score with 9 or higher should get a sedative. So what percentage of root canal patients would have a stress score of 9 or higher? So in other words, what's the probability that a patient has a stress score of 9 or higher? So to calculate this probability, I'll convert this to a z-score. This is equal to the probability that z is greater than or equal to. There's my formula here to convert to a z-score. So I want the probability that z is greater than 9 minus the mean, which is 7.59, divided by sigma, or standard deviation, which is 0.73. To simplify this, I'll plug in this into my calculator to get that 9 minus 7.59 divided by 0.73 is 1.93. So this tells me I want the area to the right of 1.93. Well, my table only gives me areas to the left. .93. Well, I can remember that the total area under the curve is 1. So the area to the right is simply 1 minus the area to the left. So this is equal to 1 minus the probability that z is less than 1.93. Well, the area to the left of 1.93 I can read off the table. Go to 1.93, my positive values. 1.9 is here. 0.03 is here. So 1.93, the area to the left is 0.9732. Therefore, the area to the right is 1 minus 0.9732, which is 0.0268. So therefore, the percentage of root canal patients with a stress score higher than 9 is 0.268, or about 2.7%.